Welcome back to another episode of Green Disruptors, where we spotlight the bold innovators shaping a cleaner, more sustainable future. Today, I'm joined by a local disruptor who's tackling the material bottlenecks holding back the energy transition. Mike Riley is the founder and CEO of NextGen, a company reimagining how we extract and source the raw materials vital to clean energy, like lithium, graphite, and silicon carbide. From his Silicon Valley roots to cutting-edge work in direct lithium extraction, Mike's journey is anything but typical. In this episode, we dive into how his team is building technologies to make U.S. supply chains cleaner, more efficient, and more eco-ethical, right from the heart of Utah. Let's get into it. All right, welcome back to another episode of Green Disruptors. I've got somebody local on with me today, so I'd like to introduce Michael Riley. I'm going to let you kind of jump in and tell us who you are and what your background is.
I'm a serial entrepreneur, which means I'm an expert in the art of self-embezzlement, which is basically where you steal money from yourself for telling yourself all sorts of stories that may or may not end up coming true. Former Silicon Valley executive, spent some time out there. Actually had an interesting company that I ran from 2003 to 2014 that I probably should have run from 2003 to 2009. We were one of the original disruptors in creating rural broadband, wireless broadband. Once upon a time, the world got to watch Quest and Comcast fight continually over the same customers, and no one else was ever served. So started working in that space for some time. Things went really well for a while. Left that for a bit and actually was involved in air medical for a little bit. Loved lots of things about that, the airplanes, the medical people and so forth, but didn't really like the fact that it left people with really, really big bills. And then just started looking around at doing some other things and became really interested in a very specific material to begin with, something called silicon carbide. Silicon carbide doesn't really have a lot of press yet, but it's going to. It's going to ultimately be kind of the tendons or the sinews that kind of hold the muscles to the bones of the electrical grid. If we're going to be powering things such that we either want to put renewable power back onto the grid or consume power out of batteries or things of that nature, all of that is going to run through wide bandgap power semiconductors that are either going to be gallium nitride or silicon carbide. That actually led me into lithium ferrous phosphate very early on, before most people were paying attention to it. The disadvantage at the time was energy density. The advantages were the number of cycles, but more importantly, the fact that it was relatively impervious and still is relatively impervious to thermal runaway events, which are the big battery fires that caused so much bad press for batteries for a while. LFP actually led us to a really unique way to synthesize graphite. And then subsequent to that, basically found myself talking to a brilliant PhD who was asking for someone to fund a methodology to pull lithium from seawater, which is incredibly dilute. And I understood enough of the mechanism that I asked if that might be possible to break the metallic. It's not really a covalent bond, it's more like a metallic bond that exists between lithium and magnesium. And we funded that, and not only was it fantastically successful in that specific goal, it also turns out that we might have the lowest water consumption, lowest power consumption, highest thermal band range, lowest harsh effluent lithium extraction methodology in the industry.
And that was kind of a happy accident, just of
Yeah, the nice thing is that some of it I get to claim that I did because I was smart and I knew where I was going and I pointed us in a good direction, but more of it was, oh wow, that worked out really well, no, didn't it? So I'll take that. I've had enough of the things that have gone the other way. And then now the material that initially led us to looking at making silicon carbide may also be able to be very useful in doing what's called antimony doping. Essentially, antimony is in short supply, and so if we can do something where we can have the equivalent function in flame retardants that antimony trioxide has by basically using this other material, then you essentially get to double the effective amount of antimony that's out there, and it's in short supply right now, but also lower the cost dramatically. So basically, NextGen has been around conceptually since 2019, but as a company since 2022. And what we do is we focus on where are there materials that we believe there's going to be a supply versus demand shortfall, where we think we can understand we have access to some unique methods for enhancing what we pull out of the ground, but also kind of create some interesting and valuable and unique sourcing mechanisms. And if we basically are able to source something that's in short supply and we have an advantageous sourcing scenario, and we can add some kind of intellectual property to it that makes it better, faster, cheaper, cleaner, hopefully all of the above, then hopefully we end up in a pretty good position to help some big companies that are struggling to figure out how to provide the materials that are needed for the renewable energy ecosystem.
Yeah. Well, congrats to you. You sound like a scientist as you're speaking with all of this. So obviously you've taken in a lot of information from the PhD guy that you've been working
Hopefully,
with.
it's not like the parrot where you're wondering if they can say the words but they don't understand them. So I'm going to hope that I'm less parrot and more novice, but I at least understand somewhat what I'm talking.
Well, I mean, I'm the novice, so whether or not you understand it, you clearly have done a deep dive into all of this. So you've got some patents in the works, right? With these
Yeah, we
processes?
have a number of patents. One's kind of an interesting one that we took over, which is embedding copper and graphite foils. Basically, will allow us to take advantage of the fact that copper does some things really well and graphite does some things really well, and haven't really started looking at monetizing that. The patents around the extraction methodologies allow us to have what right now is probably the only continuous flow method for direct lithium extraction. And from what we can tell, far greater efficacy in terms of both separating and concentrating lithium above and beyond what else is out there in the marketplace. That same methodology can be adapted to do things like manganese separation, copper concentration. We believe probably some things in nickel, pretty certain. We can actually do something with iodine. So, we're looking at those. And then this other material that has so many unique properties, I'm in the process of taking on some existing patents that help lithium sulfur batteries, solid state battery electrolytes. And then recently we've just locked up a really unique methodology for extracting lithium and further concentrating it in clays, which is about a third of the energy and 1/10 of the sulfuric acid. And we can actually use sulfonic acid instead. And all of those things mean that we should be able to kind of impart some business, technical, and environmental advantage to these different projects that right now in many cases are stuck because either they can't get enough water, they can't get enough power, they're facing environmental opposition where people are concerned about the impact to the local environment, which given the history of extraction and mining is probably a fair
Fair.
thing to be concerned about, right?
Yeah.
So our goal is to be eco-ethical, but also we recognize that the reality is the world has become such that we like to buy the cheapest thing we can, and quite
Yeah.
often that means it comes from China, and quite often that means China's basically saying they're going to do it nicely, but in fact they don't.
Yeah. There's
The bad thing is you pour stuff into rivers, it sooner or later makes its way into the ocean, and if you push stuff into the air, at some point it wafts its way over here. So, not only do we have this very real need to take the environmental implications of what we are using and or consuming seriously, we have to recognize it is kind of this big, single organism, so to speak.
yeah. There's nowhere you can put it that it's not going to affect all of us in the long run.
Exactly. You can maybe do certain things. I'll make the argument that an electric vehicle powered by a coal-fired plant that's out in the middle of nowhere, Utah, it's better than it being a tailpipe emission in the Great Salt Lake Valley, which is shaped like a horseshoe and does a really good job of compacting bad air.
It
But
sure
ideally,
does.
we figure out the right way to do it, right? So
Yeah. Well, there's probably, you know, worst, not quite as bad, good, better, best. There's a large scale there, and
in
we
the
got to get
engineering world, in the engineering world, you learn that perfect is the enemy of good enough, and all too often
absolutely.
people chase perfect when that's not pragmatic.
Yeah, well, and to me, it's like make a step forward because you might not be able to jump from worst to best or perfect. That doesn't seem probable. But if you can have all of your systems at least progressing along that trajectory, it's going to make more impacts sooner.
Exactly.
Well, let's talk locally because this is a very relevant issue here in Salt Lake because yes, we have our unique ecosystem here and we're highly dependent on the Great Salt Lake and we so water is a huge issue and definitely hot button right now. For listeners who are not aware, the Great Salt Lake was predicted to be extinct within 5 years a couple of years ago. But then we miraculously had this crazy winter where we got all this snow. And so suddenly the politicians are like, oh, it's not as big of a problem anymore. But it definitely still is. So,
It's wonderful when Mother Nature chooses to save you, but when you look at the West, we have this interesting thing called the Colorado River Water Compact, and it was formed in about 1950, and it was formed on the basis of what they believed were historical flows from the previous 100 years.
yeah,
And unfortunately, though that 100 year turned out to be the wettest 100-year cycle, and I can't remember if it was in 1600 years or six. It was a very large number. So
abnormally wet. So we made
abnormally,
all of our water packs dependent on that amount of water, which has not been the case in the last 50
exactly.
years at all.
And all sorts of things, basically, the world in 1950 was a different world than it is today,
Yeah.
right? So, the thought that you could actually ship a bale of alfalfa to China and actually have that make sense financially just really didn't occur to anybody. Yet now, we technically export our water in alfalfa because there is a mandate where basically farmers, the 1950s compact was, hey, farmers are going to feed us, so they should have first shot at the water, which I agree with. But not if you're shipping that feed to China, and then we're actually pulling water out of, the opportunity for it to be used here locally. Now, in the Great Salt Lake, we have something really unique. It's not really fed from the Colorado River, but all of the water runoff, and we have issues that whereas the soil dries, even a good winter can basically not make it to the Great Salt Lake because so much of that water has been absorbed in the soil and subsoils. But yeah, it's kind of interesting because there are people who are trying to mine the Great Salt Lake for certain things that are really in abundance elsewhere, right? I mean, if you're gonna, for example, mine the Great Salt Lake for brine shrimp, well, there's not really many other alternatives in the world, candidly, right?
Sure.
But
Yeah.
if you're going to mine the Great Salt Lake for lithium, it's about 66 parts per million. And your traditional resources that people even think are considered worth pulling lithium from are about 250 parts per million. There are lots of resources in Nevada that are 3,000 parts per million. Thacker Pass is a peak of about 15,000 parts per million, and there's even a waste pile that's 90,000 parts per million that sits next to the Great Salt Lake. But basically, there are some companies that have figured out that this might be their best chance to prevent them from having to suffer a down round on their next fundraising valuation, and so they're essentially telling half the truth. There's a scenario where they describe pulling lake water out of the lake and returning 99% of that lake water, which is true. But they're kind of glossing over the fact that they purchased the water rights for water that is currently flowing into the Great Salt Lake, and they're going to use about the exact number they gave was 10 square meters, which turns out to be about 2,600 gallons, which is about 10 tons of water. So if you're using 10 tons of fresh water to make 1 ton of lithium, and it's one of the least valuable lithium resources in the area, but it's very valuable as
66
a
compared
brine
to,
shrimp,
yeah.
and valuable in that If we have more lake bed exposed, that means more toxic dust that could get into the air and a lot of arsenic and other bad stuff there. And, we're already in a scenario where our lake, our air quality on a regular basis annually, we have the worst air in the country, and occasionally we even end up with the worst air in the world. And
Nice.
doing anything that exacerbates that may not be, the ideal if we have other options.
Yeah. As someone who is raising children here, let's look into those other options,
Children
please.
like to breathe, and their
Yeah, I
lungs are
mean, everyone
abnormally,
does.
yeah, their lungs are abnormally sensitive to the stuff that we, as you're growing, that's, the young and the elderly are the ones who suffer the most when we put, bad things into the air.
Yeah, for sure. So, the technologies that you've been working on are a great alternate solution to what some of these other companies are trying to do with lithium extraction. So, I mean, how do you come in I mean, who do you have to speak to? And like, how does that process work to show that there's a better way? And do people listen?
Yeah, it's a complex problem, So, for example, I'm hoping that we get to do something with a waste pile that sits next to the Great Salt Lake. It's actually recently been taken over by the state. It was owned by U.S. Magnesium Corp. U.S. Magnesium Corp has a very long history of doing things in a way that annoy the Environmental Protection Agency and have caused, concerns with the state and Department of Environmental Quality. And that resource has, significant lithium in it that we could process really with almost no environmental impact. But, the company that's going after the Great Salt Lake resource is a very good lobbyist who's very expensive. If I could afford a lobbyist at that level, I'd have a hard time doing it. I just don't like spending money on things that I don't really agree with the process, right?
Yeah, I feel
But the
like they're
fact of the matter is
unethical.
politics matter, right?
Yeah.
So we're in the process right now of talking to some people at the state about them taking over that resource, but then also hopefully indemnifying all the people that I would bring into that project. The gentleman who owns Renco is known to be quite litigious, and basically wealthy people can use the legal system as a hammer. However, the state has been damaged by this company quite badly over time, and would have every right to defend both its rights to, recover monies from that to solve the environmental financial baggage that's been left behind that somebody has to pick up that cost, and it's going to end up being the state. So hopefully we'll have a path to being able to communicate with the right people at the state that we've got a solution that will be good for the state and prove some things that people think can't work the way that we're going to be able to prove that they do, and that
Yeah.
might change some conversations, right? But unfortunately, money in politics always talks, and
Yeah.
money quite often does a good job of drowning out the science, and candidly, that happens on both sides. I mean, sometimes you have the crazy green enviro people who don't do a good job of actually understanding the technology, but they shout really
Hmm.
loudly. And
Yeah.
then you on the other side, you have people that basically have very serious economic interests to tell a clever version of the story, so that they're not quite telling the truth, but it promotes their economic goals.
Yeah. Well, just in saying like the amount of lake water they're extracting and having it like not using gallons. So it's like just say it in a way that people don't make the connection. That's
Well,
tricky.
and the issue is, I mean, so if you go down, for example, to the Atacama, which is the high desert of South America, they're saying, well, we're only using 10 tons of water per ton of lithium, which is way better than 1,000 tons, which is basically what happens in the Atacama, right? And in an environment where you had to have lithium, and we do, and your choice was 10 tons or 1,000 tons, I'd say go with 10 tons, right? But I'd also say go with a resource that has less environmental detriment overall, and certainly less environmental detriment that literally rings, a population center. I mean, when you take a look at this, Salt Lake Valley, we've got a couple million people living very concentrated in a very big state. It's absolutely the wrong place to do here, right? But ultimately, I think it's important for people who want to have a voice in this, and I'd love to see more people have a voice to actually do the research and find out, what the real impacts are. Because we do need lithium. We do need electric vehicles. We do need batteries to support the grid so we can use renewables more effectively.
Yeah.
And there are ways to do all of this cost effectively and eco ethically, right? But essentially in the world where we have a truly global economy, the only thing that people like private equity care about is what's the absolute cheapest way to get something.
Yeah.
Okay, that has caused us to default to China. And if we say, well, now we'd like to take into account both cost and some eco-ethical aspect, then we need to make sure we're actually checking the people. The Paris Accords were signed at a time that basically China and India promised to do some things to really shut down their coal consumption. They didn't at all. All the countries that did basically spiked their electricity prices. That's a big part of the reason why Germany is no longer a manufacturing hub. Is they voluntarily agreed to do the right thing, and China and India didn't, even though they agreed to. And so we have to be cautious that if we're approaching, let's use a more eco-ethical approach. Hold the people who are promising to do that accountable, because greenwashing
Yeah.
happens everywhere. And now we're seeing, a lot of focus on domestic supply chains. And there's the old story of for want of a nail, a shoe was lost for want of a shoe, a horse was lost for want of a horse, a night was lost. And the whole point is a very small dependency on pieces can make a very big difference in certain things. The rare earth elements that go into a F-35, you're probably talking $1 million of $100 million build assembly. But if you don't have them, then you don't have an F-35, right?
Exactly. Yeah.
So these are complex issues, but the basic facts are relatively straightforward if you can get to the right people who have the right answers. But anytime there's money involved, there are people who can be persuaded that maybe it makes sense to tell the story a little differently. I remember once upon a time there was one company that basically got to sell cigarettes for a lot longer than the others because they convinced everybody that 97 out of 100 doctors who did smoke smoked this particular brand. Okay, I mean, the commercial world does a good job of finding a way to make money and preserve market share.
Yeah. And that's human nature, unfortunately. So let's jump back to your company and all the different, avenues and ways that you can scale and grow and become a profitable business. What does that look like when you're in the midst of, like, you're still at the point where you're securing projects, developing the technology. So how does a company like this scale, and what are the challenges at the moment?
Sleep is probably one of the biggest ones, right? So basically, no, it's interesting because it's a moving and dynamic world, right?
Hmm.
So very early on, we were looking at can we be making lithium ferrous phosphate cathode active materials here in the United States? 93% of those are made in China. And the good news is, Utah, for example, has iron resources, which is the ferrous oxide. We have the phosphate resources. We have that in potash. We have that, the lithium resources. We're really unique in the fact that we have all of
Yeah.
that locally, right? And we were looking at how to do that, and it looked like it was going to make sense. And then the prices of lithium ferrous phosphate batteries fell through the floor. So the good news is we absolutely know that we could lose money making LFP also, right? So at that point we had to shift, and we're trying to figure out what to do with the work that we put into that. But ultimately you're playing a game that are a lot of moving parts are happening, and you have to kind of pay attention to where the market is and what's happening.
Yeah.
Okay.
Oh, for sure.
When we first got into DLE, there were very, very few companies doing anything, and the companies that were doing it weren't doing it well. Okay. There's now a lot of companies doing it, and there are a lot of companies doing it better. I think we still have a pretty significant advantage. But the reality is, for example, the one company I was describing earlier, their problem is they'd raised so much money. Their last valuation was at about a $900 million valuation. They'll never see that again. They'll be lucky to get back to a $100 million valuation, in my opinion. And essentially, what happens is you kind of have to keep an eye on the ball and figure out, is what I've invested going to get me to here or here? And if you've only invested it here, that's okay. You can still do
Yeah.
well by your investors and move on to the
Hmm.
next project, right?
Right.
So ultimately, what we have to do is look at the various things that we're doing and saying, how much of an impact are we going to have here? Is this a business? I came out of the software industry, and one of the things that people used to, the VCs used to, beat people up with is there's a difference between a business and a feature, right? And in some cases, we may have something that's, essentially a feature. I don't know that we can build an entire business around iodine extraction. But we can basically do something with iodine extraction that's a fraction of the cost of how people are doing it. It's much more environmentally benign, and it's very valuable to some very big companies. And so that might be something that we spin up and sell off to somebody that's
Yeah.
very concerned with iodine extraction, right? And that's the advantage of NextGen is we bounce from project to project and try to figure out, can we make an impact in what we're doing, right?
Mm. Yeah.
And we also, we look at the giants, and candidly, in this space, the giants move slowly comparatively to what I'm used to. Okay.
Mm.
But even with what I'm used to, one of my claims to fame, I helped the company. I was the principal business development person, VP of sales. It was a company that did about 900 million in sales when I joined them, and we grew them to about 1.9 billion in 28 months. And we did some really innovative things, and took a lot of money from companies like Intel and Seagate and so forth. And I'll never forget, because we actually took about $20 million from Intel and did some very early things with blade servers. And when I ran into the Intel people after that company ultimately went belly up, which meant that they didn't get their 20 million back the way they expected to, I was expecting my Intel partners to be quite angry with me. And they're
Mm.
like, Mike, no, you guys moved faster than anybody, much faster than Intel, faster than Dell, faster than HP. We learned so much from the things you were doing. Basically, our blade server technologies went so much further because you guys were fast and nimble, right? And if you've ever dealt with big companies, it's kind of interesting because you can have a big company where you want to propose something, and it takes them 9 weeks to figure out who all should be in the meeting, and then it takes them another 16 weeks to figure out how to get
Mm-hmm.
everybody in the meeting, and then the
And then it
president
takes
who wants to
another
be
six
involved.
months. Yeah.
Exactly, right?
Yeah.
And so there actually are real advantages to being small and nimble, right? The key is to make sure, as silly as it sounds, spend less money than you raise or have, right? And make sure that you spend money on things that actually make sense, right? You
Yeah.
know, but
Something that's going to be directly impactful and not be fluff. Yeah.
exactly, right? And then also make sure that you're bringing the right people to the table and giving them the right incentives, right? So, we are going to be doing some really interesting things in graphite. And the people that I've got involved in graphite are amazing and smart, but they're looking at the stuff that we're doing in lithium, which is cool. And they're going, well, that looks good, right? Well, the reality is our graphite business will probably be more valuable than our lithium business. But, everybody gets excited about everything and everybody wants to
Yeah.
do everything. And unfortunately, I'm the only person who gets to do that because I'm the CEO and founder. And I need to make sure that within the things that we're doing specifically, everybody within their lane is smarter than I am in that lane. And then if we do that, we'll build a lot of great little groups that will either evolve into their own companies, or more than likely what they'll end up doing is being a group that facilitates solving problems for really big companies, right?
Yeah.
And if we do that, we'll have a very successful company. And maybe we grow it to the point that it becomes something huge and worth billions. But maybe it just becomes a really interesting, innovative company that moves the needle in making changes for U.S. domestic supply chain resources that are eco-ethically sourced. And if that happens, I'm pretty much okay with that being an outcome too.
Yeah, I agree. And I mean, having a company that's worth billions, that's great. Like, but the potential for impact, like even if you were to sell the technology to these larger companies, like the echoing footprint of that is going to be huge and long lasting. So that's also a legacy you could be very proud of. So,
Well, and it is kind of fun because right now I think there's a lot of people, I mean, there's a lot of kids trying to figure out what to do with their life, right? And when I say kids, I'm talking,
Yeah.
people 18 to 35, because at my age, 35 is a kid, right?
I'm
But
not a kid anymore. That's good.
oh, good, okay, just barely, you barely cleared that bar. But the reality is this is something that you can become passionate about. This is something that I mean we really are going to check the boxes where we will be profitable. We will be able to create local economic development impact. We will be able to lower the costs. I mean our projects right now we expect to be competitive with China when China's cheating. So with
When
China
China's cheating.
cheating and without
Yeah.
tariffs, we think we can compete head to head. So with tariffs and those other things, that'll be a nice
It'll be a
tailwind.
better option. Yeah.
Yeah, but ultimately, an investor is going to be very concerned about putting money into something that relies on tariffs because the minute that changes, you go from a profitable dynamic to you're not making money. So
Yeah. Like
we're looking
the
we're looking for good, talented, excited, people who want to actually have an impact. But the good news is we think we're going to build a business that's going to be worth quite a bit.
Yeah. Well, that is exciting because I think a lot of that generation too really cares about environmental impacts. And so I bet there's a lot of people that are interested in careers that are making a positive change and that are working for companies that are in line with their aligned with their values that way. So sounds
Well,
like a
and
win-win.
AI is going to, first of all, I don't know that we need another SaaS dog walking app, right? And people are doing those. But AI is going to basically change some things, right? I mean, I met a young man Saturday night. His grandfather was being honored for something, and I asked him what he was doing. And usually, I'm ready to tell people, "All right, look, if you want to make money, become an industrial electrical engineer and rebuild the grid," right? And I said, "What are you doing?" I decided not to go to college. I'm going to become an electrical engineer. He said, "I really think rebuilding the grid's the next big thing." And I was like,
You're like, wow.
holy crap, my buddy's got a super smart grandson, right? I had to tell him afterwards. So, but yeah,
That's
I mean,
great.
the reality is AI is going to take over a lot of inane things. The code monkey stuff's going to go away, and there's a lot of things that AI is going to be able to do. But if we're going to make materials, if we're going to make things, if we're going to fix grids, if we're going to basically solve real world problems, that's going to take people with hands and brains that are connected that are
Yeah.
actually doing things.
Yeah, I agree. Well, thanks for you've got your hands in a lot of pots, but all very exciting. And I like what you said about make the smartest people be really focused on one thing, have them stay in their lane, and work nimbly as a team. And I think you're headed for great success. So
Knock on wood, as I usually
knock
say.
on wood.
So.
All right. Well, thanks for the conversation, Mike, and thanks for the local impact, especially. And
I
we'll be in
appreciate the
touch.
opportunity to share our story and thank you for doing what you're doing.
Yeah, absolutely. That wraps up our conversation with Mike Riley from NextGen. I hope you found his insights as fascinating as I did, from smarter ways to extract lithium to making sure we don't sacrifice our local ecosystems in the name of clean energy. If you're passionate about sustainable materials, domestic innovation, or you're just curious how startups can outmaneuver the giants, this is one to share. Don't forget to rate, follow, and share Green Disruptors wherever you listen to podcasts. And we'll catch you next time with more change makers driving the future forward.